teacher Atepe. Our lesson today is about volume. So the last lesson we discussed about volume, but today we want to expand more on volume by giving many examples, of course, for you, the learners, to understand more about this topic. So our example one is that I will write on the board. I'll write here on the board. We have this question. Find examples. These are examples. Example one. Find the volume of the figure below. So I will sketch down, write the figure here. That is the figure. So when you look at this figure, we have the upper figure that looks like more like a half a cylinder that has been cut through. Then we have the down figure that looks like a cuboid. We have this figure that looks like a cuboid. So we have, that is our 9 centimeter, that is 14 centimeter, and that is 12 centimeter. So the formula first comes in volume is equals to, we have two figures, of course. When you look at this figure from this angle, we are able to say this is a cross-sectional. And of course, for us to find the volume of this figure, we are going to take the area of the cross-sectional and we are going to multiply it by this length. And the area of the cross-section, of course, we have the semicircle, that is the semicircle part, that is a half a circle. Then we have the rectangle. So when we combine the two, of course, we come up with a cross-sectional area. So we're going to find the area for this, then the area for this, then we're going to add them up, then we shall multiply by 12. That is our length. So we are saying the volume for this, it is the cross-sectional area multiplied by the length. So our cross-sectional area, it is the half a circle, then we have a rectangle. So the half a circle is a half times half pi r square, which is half times 22 over 7 times r is 7. So multiply by 7, multiply by 7. So that is this part. Then for this part, we are going to take the length times width. That is length times width, which is equivalent to 9 times 14. So we look at this one now. We substitute 2, 1, 2, 11, 7, 1, 7, 1. So 11 multiplied by 7, we have 77. Then for this, we have 14 times 9. Roughly, we have 14 times 9. That is 36. And that is plus 3. That is 11. That is 1. That is 12. Sorry. That is 12. So 126. So we are going to take 126 plus 77. That is 3. And that is 0. And that is 2. So the cross-section area, this part, is 203 square centimeter. Then we are going to take this area now. We multiply by the length now, which is 12. So we're going to have 203. We're going to multiply by our length, which is 12. 0 to 604. Let's add 6, 3, 4, 2. So our volume now is 2,436. That is cubic. That's our first example. From the previous work I gave out, I didn't explain this, but now at least for you, the learners, you are now able to know how to calculate and find out the volume of this figure. Then our example 2. Let's move to our example 2. Or number 2. We have a cylinder. Find the volume of a cylinder or cylindrical figure below. So let's sketch our figure there. So our height, we have 12. We have our radius, 3.5 centimeter. So the solution for this, we are saying the uniform cross section area multiplied by the height. We are saying the uniform cross sectional area multiplied by the height, or in other words, we are going to say it is pi r square h. So the pi r, we are referring to the bottom. This bottom part, of course, it is a circle, it is circular, so that's why we are saying it is pi r square. Then we are multiplying by the height. The same figure, when you place it on a lying position, this is a standing position, we are saying pi r square height. But when you turn this figure on that, for example, if the figure is on like this, like that, so our radius, we are saying 3.5, then now this one becomes the length, which is 12. So it now depends on the position, the figure, either standing or on a lying position. So if it is standing like this, we are saying pi r square h. So our pi, we are going to use 22/7, that is our pi. Our r is 3.5, multiplied by 3.5, then our height multiplied by 12. So of course it is cubic. So let's substitute 7 goes there 1, 7 goes there 0.5. Then we assume the decimal. We take 5 multiplied by 35. So we have 35 multiplied by 5, that is 5, that is 17. So then you multiply by 22, because it's the, or we can put the decimal point back, it's a 2, so 1, 2, 1.75. Again, we're going to take, multiply by 22, again by 22, so 1.75 by 22, that is 10, that is 15, that is 3. That is 10, that is 15, that is 3. So we have a 0, a 5, 8, and 3. So we have 38.50. Then again we're going to multiply by 12. So 38.50. Let's multiply by 12. By 12. So 0, 5, 0 again, 16, 17, 6, and that is 7. So let's start. 0, 0, that is 12, carry 1, that is 16, and that is 4. So we had our decimal point to be there. So definitely our volume now, it is 4, 6, 2, 0, and of course it is cubic. We move to our number 3. Our number 3, we are still on different figures. We are still on different figures. So we have a figure like this. Figure like this. So this is like a cuboid. Then on this, there is something that has been chopped. So this part has been chopped. So we have our length to be 18. We have 18 centimeter. Width to be 15. And the height is 13. So the question says a hole of diameter 7 was bored lengthwise. A hole of diameter 7 centimeter was bored lengthwise through a cuboid, as shown below. Calculate the volume of the figure remaining. Just say the figure below. So now this is the figure. We are saying that a hole of diameter 7 centimeter was bored lengthwise. So this is the hole that we are referring to. You can see that part has been removed, has been chopped off. So the question says, find now the volume of the remaining part. Of course, we are going to say volume first. We have two figures whereby we have the chopped part that look like a cylinder, and we have the old figure that looks like a cuboid. So we are going to find the volume of a cuboid, which is length multiplied by width multiplied by height. So our length is 18 multiplied by our width is 15 times our height is 13. In bracket, you say it is cubic. Then, so let's have 18 times 15. That is 8, that is 1, 40, that is 9. So 0, that is 17, that is 2. So we have 270 multiplied by 13. 0, 7, 2, 0, 21, 6, that is 8, 0, 1, 15, that is 3. So our volume of that cuboid is 3510. The volume of the cuboid is 3510 or 3,510 cubic. So at this level, of course, we have now the volume for the whole figure, but we need to find the volume that has been that space. Of course, volume is the space occupied by an object. So there is a space that has been created. So what has been chopped off is, of course, something like a cylinder. So again, volume now of a cylinder, it is the pi square h. Then we have our pi is 22 over 7 multiplied by our r. We have been told the diameter is 7, so our r is 3.5 times 3.5. And our height, we are going to use this length, which is 18. So now let's try and substitute 0.5. So we have 0.5 multiplied by 22. So we are assuming 22 times 5, that is 0, that is 11. So if the one decimal place, it becomes 11. So you take 11 multiplied by 3.5. So you have 11 times 35. That is 3, 3, 5, 5. 5, 8, 3. One decimal, remember it's a one decimal, so you bring back the decimal, 38.5. Again, you multiply by 18. So you have 385 times 18. So that is 5, 8, 3. 8 times 5 is 40. You carry 4. 8 times 8 is 64. Plus 4, 68. Then you carry 6. 8 times 3 is 24. Plus 6 is 30. So, of course, when you add, we have 0, we have 13, 31, we have 9, and we have 6. One decimal, it will be 693. So definitely our cylinder there is 693 cubic. So finally now, we are going to find the difference between the volume of that cuboid, then subtract the volume of the cylinder. So our last part is now getting the difference between the volume of the cuboid, which is 3,510. We are going to subtract this from this. So finally now, we have 3,510. Of course, subtract 693. So that is 7. Then we borrow 1 from there, make it 10, that is 7. There's nothing left. We borrow again from there. So that is 10, that is 1. Then that is 4. We come back to 3. That is 14 minus 6 is 8. Then 2. So now our volume of the remaining part is 2,817 cubic. So as the learners now, what you need to do is you go back to the books, look for these questions, try and work them out. Why? It is because the more you work them out, the easier things become. Our last example is coming. Our last example before we wind up the lesson. So we have our last example. We have a figure like, first let me write the question down. That is our example 3. The question says, half of a cylinder was cut from a solid as shown below. So let me sketch the diagram for you. So we are saying sketching of this diagram becoming hectic. Something like that. That is a rough sketch of the diagram, because we're saying half of a cylinder was cut from a solid as shown below. So we are going to use this, the next one. So the question says, find the volume of the remaining solid. So find the volume of the remaining solid. So again we have two diagrams, of course in one. There are two diagrams, or there are two figures in one. One, we have a cuboid and there is a cylinder that has been chopped off from that cuboid. So we are going to find two different volume. That is one, our number one, it is volume of that cuboid, which is length multiplied by width multiplied by height. Our length in our diagram we have to be 20. That is 20. Our width is 14. Our height is 15. So our length will be 20. Our width is 14. Our height is 15. Then for the chopped part, which looks like a cylinder, the volume is a half, because it is a half that has been chopped. So it is a half pi r square h. So that is a half, 22/7. That is our pi. Our r is 7 multiplied by 7. Then our h, which is height, is 15. So let's first work out this one. So we have 140 times 2, that is 280. So we have 280 multiplied by 15. That is 0, 8, 2. That is 0, 0. That is 14. 0, 0. That is 12. That is 4. So we have this one to be 4,200 cubic centimeter cubic. Then we go for the half that have been chopped. So we have achieve by simplifying here. 2, 1, 2, 11. 7, 1, 7, 1. 77 and 15. So 7, 7, 35, 35, carry 3, 35 again, 38. So add, that is 5, that is 5, that is 11. So we have this one, the volume is 1155. So for us now to find the remaining part, again, we are going to find the difference between the volume of the cuboid and the volume of the half-chopped cylinder. So definitely now we have 4,200 minus or subtract 1,155. That is 5, that is 4, that is 0, that is 3. So our volume is 3,045 cubic centimeter. So just to wind up the lesson, I would like the learners, you go back to your books, and of course I will give the work later, so that now you go back to the books, and of course you dig deep in your books, and of course so that you are able to be closer and closer to the books. So our lesson has been good, and of course I will stop there. Thank you for your listening.